I'm Dr. K.V. Girija, Associate Professor, Department of Science and Humanities. I'm going to present a topic, vector spaces. In that, I'm going to present about complex matrices, vector inner product spaces, and Gram-Smith orthogonalization. The topics covered in vector spaces are complex matrices definitions, problems, vector spaces definitions, and Gram-Smith orthogonalization. Here, first topic is complex matrices. Here. Definition. A matrix which has at least one complex number as its element is called a complex matrix. For example, A equal to 2, 4 plus I, 4I, 3I, 6 minus I, 2, 6, 4 minus 2I, 1 minus I. In this, some of the elements 3I, 4 plus I, 4I, 4 minus 2I, and 1 minus I are complex numbers. So A is called as complex matrix. Next, conjugate of a complex matrix. If a matrix A is having complex numbers as its elements, the matrix obtained from A by replacing each element of A by its conjugate is called the conjugate of the matrix A, and it is denoted by A bar. For example, let A equal to A plus IB, X plus IY, P minus IQ, lambda minus I mu, alpha plus I beta, gamma plus I delta, R minus IS, mu minus IV, theta plus IY. All these elements are complex numbers. Its conjugate is A bar. Here A plus IB become A minus IB. X plus IY became X minus IY. Similarly, P minus IQ became P plus IQ, and so on. Then A bar is called as conjugate of the given matrix. Next, in continuation of conjugate of a matrix, next is conjugate of a transpose matrix. The conjugate of the transpose of a matrix A is called conjugate transpose of A, and it is denoted by A par theta. A par theta equal to conjugate of A dash, that is A dash bar. The definition for transpose matrix is conjugate transpose is this A dash bar. For example, let A equal to 2 plus 4I, 3, 5 minus 9I, 4, alpha plus I beta, 3I, 2 minus 5, 4 minus I. In this, A par theta equal to nothing but it is conjugate transpose or transpose of a conjugate. Whatever it is, both are same, and it is denoted by A par theta. It is given by the 2 plus 4I became 2 minus 4I, then transpose. So first row will become column and column will become row. So our second row first element become, when you go there to 4 and 2, then 3 alpha minus I beta conjugate minus 5, then 5 plus to 9I, then minus 3I, 4 plus I. So in this conjugate and also transpose, this is called A par theta. It is the conjugate transpose. Now, properties of conjugate transpose. For any matrix A dash bar equal to A bar dash is equal to A dash bar. What I said, transpose. This is conjugate transpose. This is transposed conjugate. Transposed conjugate of a matrix is equal to the conjugate of its transpose. For any matrix A par theta, the whole power theta equal to A. If A and B are two matrices conformable to addition, then A plus B the whole power theta equal to A power theta plus B power theta. Fourth property is for a matrix A, Ka the whole power theta equal to K into A power theta, where K is a scalar. Fifth property is if A and B are two matrices conformable to the product AB, then AB the whole power theta equal to B power theta, A power theta. These are the properties of transposed conjugate. Next, Hermitian matrix. A square matrix A such that A dash bar is equal to A is called the Hermitian matrix. That is, if Aij equal to Aj bar for all values of I and j, that is A for theta equal to A. Now, for example, A equal to alpha, lambda plus I mu, theta plus I phi, lambda minus I mu, beta. This is the matrix given A. A dash is transpose. That is, all the row will become column and column will become row. Next is A dash bar. That is, we have to find out the conjugate of all the complex elements. That is, for example, here lambda minus I mu is given as a 1, 2 element. That is, that become lambda plus I mu. Theta minus I phi became theta plus I phi. Then lambda plus I mu became lambda minus I mu and so on. Okay. Now, this is nothing but our A, given A. So, A is Hermitian. So, what we have got, if A dash bar equal to A, then the given matrix A is called Hermitian matrix. Next, skew Hermitian matrix. A square matrix A such that if A dash bar is equal to minus A, then it is called skew Hermitian matrix, provided Aij equal to minus Aji bar for all values of I and j. That is, A power theta equal to minus A. Now, for example, A equal to 2i, 2 minus 3i, minus 2 plus i, 2 minus 3i, minus I, 3i, and 2 plus I, 3i, 0 is given. Here, A dash. A dash means we have to find out the transpose of the given matrix. Next is A dash bar. What do you mean by that? Bar means we have to find out the conjugate of each complex number. That is, we have to change the sign of the imaginary part. So here what is that? 2i became minus 2i. 2 plus 3i becomes 2. 2 minus 3i become 2 plus 3i. 2 plus I become 2 minus I. Minus 3i become minus 2 plus 3i. Minus I became plus I. Then 3i become minus 3i and so on. Here you can, if you take minus sign out from this, we will get minus if we take out 2i, 2 minus 2 minus 3i, like that. Is it not? This is nothing but our given A. So if A dash bar is equal to minus A, then it is called, this A is called as skew Hermitian matrix. Next, properties of Hermitian and skew Hermitian matrix. First one, the diagonal elements of Hermitian matrix are necessarily real. The diagonal elements of a skew Hermitian matrix are either purely imaginary or zero. Third property is every square matrix with complex elements can be uniquely expressed as the sum of a Hermitian and skew Hermitian matrices. That is nothing but A equal to half of A plus A power theta plus half of A minus A power theta. Here, half of A plus A power theta and this half of A minus A power theta are Hermitian and skew Hermitian parts of A. This is a very important property. Depending upon that, there are problems. Next, unitary matrix. A square matrix A is called unitary matrix if A into A power theta equal to I, where I is an identity matrix that we know everybody, and A power theta is the transpose conjugate of A. Now, for example, you see here, example problem itself, it is given as prove that the matrix given is unitary. What is our, give name to that given matrix as A equal to 1 by root 3, 1, 1 plus I, 1 minus I and minus 1. A dash is 1 by root 3, 1. What is this? A dash means row will become column and column will become row. Is it not? Now A dash bar, that is equal to 1 by root 3 into 1. What is that? Bar. Bar means the sign will get changed. It will become 1 minus I, then 1 plus I minus 1, which is equal to A bar theta. Is it not? So A dash bar is equal to this we got. Now check whether A into A power theta is I. Now what is our A given? 1 by root 3, 1, 1 plus I, 1 minus I and minus 1 into A power theta is what we found out. That is 1 by root 3, 1, 1 plus I, 1 minus I and minus 1. You take this 1 by root 3 to front. So it will become 1 by 3 into, when you multiply these two, this into this. 1 into 1 plus 1 plus I into 1 minus I, 1 into 1 plus I plus 1 minus 1 plus I into minus 1. When you multiply this, we will get for the first one as 3. When you multiply the next one, it will become 0. Then second row, first column will give you, when you multiply and add, it will become 0. Then second row with second column will give you the total as 3. So we will get 1 by root 3 into 1 by root 3 is 1 by 3. This will become 3003. When you take this 3 inside, it will become 1001, which is nothing but the identity element. Okay, now what we got, this is the matrix given. We have to prove it is given, matrix is unitary. For that, we are finding out, giving name to this as A. This is A dash bar we are finding. If under definition of unitary matrix, if A into A power theta is I, then the matrix is unitary. So A into A power theta you find out, that is I. Therefore, the given matrix is unitary. Next, properties of unitary matrices. If A is a unitary matrix, A dash is also unitary. That is, A transpose is also unitary. If A is unitary matrix, A inverse is also unitary matrix. Third property, if A and B are unitary matrices, then AB is also unitary matrix. Now, this is the thing we got, that is, in complex matrices, we have studied about what is a complex matrix, properties of complex matrices, then conjugate of the complex matrix, transposed conjugate, which is A power denoted by A power theta, then Hermitian, skew Hermitian, properties of Hermitian and skew Hermitian matrices, then unitary matrix studied. Thank you.